What's going on, everybody? Type annotation is a way of documenting your Python code by adding types to variables, parameters, functions, and much more. So you and any other developer can easily know the data type expected in your code. IDEs and linters also use typing to suggest the relevant attributes and methods for an object. We are going to use a static type checker that reads Python code, analyzes it, and reports any incorrect type issues. Without further delay, let's get started. In Python, you can easily declare a variable by saying name equals a string data type. You don't need to explicitly say the type of this variable is a string. As a matter of fact, this variable, which is a string, can be changed to another data type later. So you can say name equals 10, which is an integer. Python will not prevent you from doing this because it is a dynamically typed language. This means the type of a variable is allowed to change over its lifetime. The opposite of dynamic typing is static typing. In static typing, variables are not allowed to change types once they are declared. In most statically typed languages, static type checks are performed without running the program, so it is easy to spot any type errors before running a program. Type annotation in Python is also called type hint because it doesn't enforce type checking itself. How can we specify the type of a variable when we declare it? Immediately after the variable name, we need to bring in a colon followed by the type string. In this case, the type of variable A is a string. Age equals 10. So we can specify the type of age to be int. For integer is active equals true. The type of is active is a Boolean data type, a bool. Also for length, which is a float, 2.25 size, the type is bytes. We don't need to do any import to make use of these basic types. Binary of text. Now, let's see how we can specify the expected types for elements within collections like lists, tuples, sets, and dictionary. Let's declare a new variable names equals. We can specify the type of this variable as a list data type. The type of elements within the list can be specified in brackets, string. This means names is a list data type and elements in the list are strings. Let's say scores, list data type, and the type is int equals 1, 5, 10. We can also make use of a set data type values equals a set 1, 5, 7. The type of the variable is a set and elements within the set are integers, so we can say int. User info, which is a dictionary, let's say name, and the value is Ray. Dict. For a dictionary, we need to specify the types of both keys and values. The type of the keys is string, and value is also a string data type. Now let's make use of a tuple. Items equals a tuple 1, 6, 8. Now the type of the items within the tuple are integers, so we need to say int. Everything from line 8 to line 17 works on Python 3.9 and above. On Python 3.8 and earlier, we need to import the classes from the typing module. Python 3.9 and above. For Python 3.8 and earlier versions, we need to import from the typing module. From typing, import list, tuple, sets, and dict. Let's copy what we've written before. So we can say name underscore 2. We need to make use of the list from the typing module. We also need to make use of the set from the typing module, dict from the typing module, dict, and also a tuple. They are all capitalized. If the items in a list or a tuple can be of different types, then we can make use of the pipe symbol to signify that. In this case, let's put 10 and 12. So we can make use of the pipe symbol to signify that this list can contain a string data type and an integer. Using the pipe symbol is the same as using union from the type module. From the type module, we can make use of union. So we can specify the type of this list as a union of ints and string ints. This means the item in this list can be a string or an integer. 20. You can use the pipe symbol to signify that a variable could have a non-value. Let's say level. The type of level can be int or none. This means this level can have a non-value. Let's say 10. This is equivalent to using optional from the typing module. We need to import optional. Now we can say level 2, optional, and the type is int equals 10. Level 2 could have a non-value since we are making use of optional. Next, let's move on to function annotation. We can specify the type of a parameter by using a colon followed by the type int. The type of y, which is a parameter, is int. The return type comes before this colon. We need to use an arrow symbol. So this is how we can annotate a function. We need to specify the type of the parameters, and also we need to mention the return type. The return type is an integer. If I was to specify the type of y to be a string data type, str, and use a static code analysis tool, then an error should be reported. Let's install MyPy. Pip install MyPy. So we have installed MyPy. To make use of MyPy to run analysis on this code, we need to write MyPy and the name of the file typing guide.py. MyPy reported an error, unsupported operand types for plus, int, and string. We need to modify this to be an int. Now, let's see how we can annotate a generator function. We are going to create an infinite number generator, infinite gen start, which is an integer, while starts yield starts plus 1 starts plus equals. In the first iteration, the value in front of yield is returned to the caller. In the next iteration, the start value is incremented and the loop body is executed again. I have a video explaining generators. Check the link below. A generator function returns an iterator. So we can specify the type, the returned type to be an iterator. We need to import iterator from the typing module. From typing, import iterator. The value returned by this generator is an integer, so we need to specify the type of the returned value to be an int. Let's run MyPy again to see if there is any issue. Let's change the int to a string data type, string. This line of code is going to throw an error, string plus a number. Let's run MyPy on the code to check for any issue. 2 errors reported. Let's see what the errors are. Unsupported operands for plus, string, and int. This means we need to change the start to int. Let's run the analysis again. Now we are good to go. A function can be passed as an argument to another function because functions are first-class citizens in Python. I'm going to create two functions to explain this. Def greet, it returns none, print hi. Now let's create the second function, def say hi. Func, it also returns none. Within this function, we want to call the passed function. For us to be able to call this parameter in the function body, then it must be callable. We need to mention that this function is callable. Let's import callable from the typing module. Callable. This parameter is callable. It must be callable. We can check the callable class to see how it is used. The first part is the parameter. The second part is the returned value. Signifies a function that takes a single parameter of type int and returns a string. This function does not take any parameter, so we can say an empty list and the return type is none. For me to call the function say hi, then I need to pass a function which is greet. When we run this program, the expectation is that this part of the code is executed, which is this function call. Let's run the program. Now let's try to pass an object which is not callable, a string. Without running this code, let's run an analysis on it using MyPy typing.guide. MyPy reported an error. Argument 1 to say hi has incompatible type string. Expected a callable. Alright friends, your custom defined classes are valid types. So when we create an instance of this class, we can annotate the variable with the class. Let's create an instance of the cat class, cat1 equals cat. We need to pass the name, let's say name, and the age, let's say 10. We can specify that this variable is of the cat type. We need to bring in a colon and then the type, which is cat. This group variable is a class attribute because it is shared across instances of the cat class. You should not modify this variable from an instance. Instead, you should modify it through the class. Let's use the typing module to specify that this variable is a class variable and should not be modified from an instance. We need to say from typing import class var, which means class variable. So we can annotate this variable with class var and the type of the variable is specified in brackets. This is a string data type, str. Let's try to modify the class variable from an instance. cat1.group equals new group name. We shouldn't do this. Let's use MyPy to run an analysis on the code. The error is coming from line 77. Cannot assign to class variable group via instance. We are not meant to modify a class attribute from an instance. Constant variables should not be reassigned after declaration. You can use the final class from the typing module to specify that a variable is constant. We need to import final from the typing module. From typing, import final, which is a class. Let's declare a constant base underscore URL with oneray.com. This is the convention used when naming a constant in Python. A constant is not expected to be modified once it is declared. So we can say final. Let's try to reassign the base URL to base URL equals google.com. We can now run MyPy to report any issue. Cannot assign to final name. Similar to the final class, we can make use of the final function, which is a decorator. A final method should not be overridden in a subclass. I'm just going to copy the previous class we declared. the cat class. I'm going to remove this. Now let's specify that this method is final. When a method is final, it doesn't support overriding from a subclass. Let's create a subclass for the cat class. Let's say class meow. This class inherits from the cat class. And within the subclass, let's try to override the move method. This class declaration should throw an error because we are trying to override the move method. Remember that the move method is final and it shouldn't be overridden. Let's run my py on the file. I'm going to remove this. Now let's run my py. Cannot override final attribute move previously declared in base class cat. Forward reference is when you reference a class before it is defined. Let's create a function which uses the cat class. Def send the source to be cat. The cat class is referenced before it is defined. This will lead to undefined error. There are two ways to fix this error if you intend to use a class before it is defined. The first approach is to wrap it in a quote, single or double quotes. So that is the first approach. Let's run my py on the code. I'm going to comment out this. No issues found in the source file. The second approach is to import annotations. We need to say from future import annotations. We can then remove the quotes we used before. Let's run my py on the code again. No issues found. The two approaches will work as long as there is a class of the cat name later on in the file. An iterable is any object that you can perform a loop operation on it. Examples of iterables include lists, tuples, sets, and dictionary. Let's create a function that accepts an iterable as a parameter. Def loop, the parameter is items, for each in items. Print each. This function returns none. So we can say from collections.abc import iterable. The type of item is an iterable, and the iterable should contain integers. Int. I need to mention that callable, iterator, and similar types from the typing module are duplicated. As you can see, we now have callable from the collections module. The same for iterator, iterable, and the likes. It is recommended to use the respective imports from the collections.abc module. Now let's talk about mapping and mutable mapping. Mutable mapping. Mappings are data structures that map keys to values. A common example is a dictionary. We use mutable mapping if we intend to mutate the object. If we don't intend to mutate the object, then we use the mapping class. Let's try out an example. Def update dict. Parameter is info, and this function returns none. Let's say the type of info is mapping, and you need to specify the type of the key and value. The key is expected to be a string data type, and the value is also a string. Info, we want to update the value of name in the info. The code editor is already showing us a warning. Fix this. This method is responsible for setting an item in a mapping type. Now let's run my py on the code. There is an error identified. Unsupported target for indexed assignments. We are not allowed to update the content of info because it is of the mapping type. If we intend to update info, then we can make use of mutable mapping. The type is mutable mapping. As you can see, the warning is gone. Let's run my py again. No issues found. I believe you can now see why you should adopt typing in your Python code. It makes your code more readable. You catch errors early in development. Overall, it improves code quality. Don't forget to subscribe, like, comment, and share. Thanks.